Hello everybody, this is Matt Jedi V, and today we're going to be attacking the 2022 AMC8 from 21. The problem reads, Steph scored 15 baskets out of 20 attempts in the first half of a game, and 10 baskets out of 10 attempts in the second half. Candace took 12 attempts in the first half, and 18 attempts in the second. In each half, Steph scored a higher percentage of baskets than Candace. Surprisingly, they ended with the same overall percentage of baskets scored. How many more baskets did Candace score in the second half than in the first? And as you can see here, the problem gave us a nice table to summarize the whole game. So Steph scored 15 out of 20 in the first half and 10 out of 10 in the second half. And we don't really know Candace's yet, so we're going to just label them X and Y for now. So X is the amount of baskets Candace scored in the first half, and Y is the amount of baskets Candace scored in the second half. Now the problem gives us a constraint. It says, in each half, Steph scored a higher percentage of baskets than Candace. So what does this mean? This means that Steph and the fraction in each half is going to be greater than the fraction of Candace's in each half. So let's just write it. For the first half, 15 out of 20 is going to be greater than x over 12, right? The fraction for Steph is greater than the fraction for Candace. And we can reduce 15 out of 20 to 3 over 4. We divide 5 by both sides. So after this, we can multiply both sides by 3 to make each fraction have a common denominator. So you get 9 over 12 is greater than x over 12. And now from here, it's very easy to see that 9 is greater than x. And we can rewrite this as x less than or equal to 8. So this is one constraint that we have gotten. Let's do it for the second one. For the second half, it's much easier since 10 out of 10 is just 100%. So that means that y just has to be anything other than 100%. So y over 18 has to be anything less than 100%, so y has to be less than or equal to 17. It just can't be 18, that's the only constraint. So these are the two constraints. Now it's like the second constraint the problem gives us. It says, surprisingly, they ended the same overall percentage of baskets scored. So what does this mean? That means that the total fraction combining the first and second half for Steph and Candace are the same. So let's look at the fraction for Steph, since we're given all the values. So adding the denominators, there's a total of 30 attempts. And adding the numerators, there's a total of 25 attempts. So that is a total of 25 out of 30. Now similarly, for Candace, we can do the same thing. So for the denominator, 12 plus 18, 30. So that's very convenient. That means that since the denominators are the same, that means that the numerators also have to be the same to the same overall percentage. So since 25 and x plus y have to be the same, we can write the equation x plus y equals 25. Now, looking at these two constraints, I already noticed one thing. 8 plus 17 is 25. So what does this tell us? That means that the maximum possible value of x and y is 25, which means that x and y have to be 8 and 17 respectively. So right here, we know that x equals 8 and y equals 17. So given this, we solve the problem. Since how many more baskets did Candace score in the second half than in the first? It gets 17 minus 8, which is 9. So that's answer choice C. So thank you for watching. May the force be with you. See you next time.